All right, hello physics students and welcome to this video lecture on forces. So to begin, we need to know what a force actually is. Okay, a force is a push or a pull on an object, and it's also very important to note that forces result from interactions between two objects. To give you an idea of what that looks like, let's say that I have a wall and I have a person who apparently has a very long torso, and this person has rollerblades on. Now, currently, we can see that this person and this wall are not touching. Okay, there's nothing going on between this person and the wall. So there's no interaction going on there. We know that there's no forces going on between this wall and the person. However, let's say that my person reached out to push out against the wall. I don't know what's going on there. That's horrifying. But anyway, let's say this person is now pushing off of this wall. Well, here is where we can now say we have an interaction going on. So because this person is now interacting with the wall, this person can push off the wall, and then it can move in this direction. Okay? So big key here is that a force is a push or a pull, but it results from an interaction between two objects. In this example, that interaction was between this person and the wall. Now, are there different types of forces? The answer to that is yes. And we're going to be talking about many, many different types of forces. However, those forces can get broken down into two categories. We have contact forces and we have non-contact forces. Okay? Now, these two categories are pretty self-explanatory. Contact forces are when two objects are actually physically touching. Okay, so contact forces would be objects physically touching. And then non-contact forces, by that logic, the objects are not physically touching. So these ones are a little bit harder to understand, I think. So like, for example, contact forces, well, we have a contact force up here because that person was touching the wall. However, how can we have a push or a pull when objects are not physically touching? Another way that we can think about these non-contact forces, we can call them attraction forces. So imagine you have two magnets. Well, those two magnets are being pulled towards one another, and yet they're not physically touching at first. So we can still have interactions between two objects, even if they're not touching. And these will make more sense as we move on in this class, but I just wanted to give you a brief description of them in this video lecture. So, to summarize this slide, a force is a push or a pull, which is caused by some type of interaction between two objects, and there are different types of forces. And they can be summarized into two categories: contact forces and non-contact forces. So now that you have an idea of what forces are, a very general idea of what forces are, to get deeper into this unit, we're going to be discovering these things called Newton's laws of motion. So really smart guy, Isaac Newton, came up with these, and these laws actually explain how motion works. Okay, the previous unit that we covered, we were learning how to describe motion through a variety of ways, whether it was verbally, whether it was graphically, whether it was mathematically. Well, now we want to actually explain how motion works. So why are things moving? Why are things not moving? The first law that we're going to uncover today is Newton's first law, which states that an object at rest stays at rest, and an object in motion stays in motion with the same speed and direction unless acted upon by an outside unbalanced force. And we can very simply state that, well, we can concisely state this law by saying objects want to keep doing what they are already doing. Okay, so if an object is at rest, that object wants to stay at rest. If an object is in motion, that object wants to stay in motion. Now, a real-world example of Newton's first law to give you a little more context. Let's imagine that you have an open container of liquid in your cup holder in your car. Let's say it's a cup of coffee. And you're driving down Losey Boulevard at 30 miles per hour. And you all of a sudden have to come to a screeching halt. Well, what is that coffee going to do? Well, it's going to fly forward and splash right into your dashboard. Now, why is that? Well, your coffee was in motion, your car is coming to a stop, but that coffee wants to keep moving. So again, that coffee keeps moving, splats into your dashboard. That's a very real-world example of Newton's first law. The coffee was in motion, it wanted to stay in motion. So while, again, we have this big, long definition here of Newton's first law, if for today you can remember one thing, it's that objects want to keep doing what they're already doing. That's kind of our layman's term way of stating Newton's first law. So remember that objects want to keep doing what they're already doing. All right, so you can notice here that I have the same slide up that I did on the previous, previously. The reason for that is I want to delve a little bit deeper into Newton's first law. We have a very important vocabulary word within Newton's first law, and that term is inertia. Okay, and inertia is the resistance an object has to change the state of its motion. Now we can state the definition for inertia even a little more concisely, and we could say that inertia is the tendency for an object to continue doing what it's already doing. So again, if an object is at rest, that object wants to stay at rest. Now, inertia, though, is dependent on something, and that something is the mass of the object. Okay, now what I mean by that is the more mass an object has, the more inertia it's going to have. Okay, more mass means more inertia. And then by that logic, less mass is going to mean less inertia. So now an example of this, to help you visualize this a little more. Let's imagine that we have a person on top of a cliff, and they're dropping both a baseball and a bowling ball. Well, which one of those objects is going to be more difficult to stop from moving? I think we can all agree that the bowling ball is going to be very difficult to stop moving once it's dropped from a cliff. And why is that? Well, that bowling ball has far more mass than the baseball does. Therefore, the bowling ball has more inertia, and therefore it's going to be a lot more resistant to changes of its motion. Okay, so again, to wrap up this slide, inertia is the resistance of an object to change the state of its motion. So the more mass an object has, the more inertia it has. The less mass an object has, the less inertia it has. So more mass, more inertia, that means it's going to be more difficult to change that object's motion. Less mass, less inertia, it's going to be easier to change that object's motion. So to wrap up this video lecture, a force is a push or a pull that's acting upon an object through an interaction. Okay, we have a few different categories of forces. We have contact forces, non-contact forces. Newton's first law, our first of Newton's laws of motion, states that objects want to keep doing what they're already doing. And that's because of this idea of inertia. So I hope that this video lecture was helpful. Again, this is your SparkNotes version of a forces intro. And for the remainder of the week, we are going to be applying this stuff. So take care, physics students.